In this podcast, we're going to start Chapter 7, Section 3, and talk about percentage composition and how to go about doing those calculations. So percentage composition is a percent by mass of every element in a compound. Every element in a compound. So you have to make sure that you assign a mass for each element. The formula for this, or the equation, is percent composition is mass of the element over total mass of the whole compound times 100, and the times 100 is what puts it as a percentage. So make sure you get that in your notes. The first example we're going to look at is finding the percentage composition of Cu2S. What is the name of Cu2S? Hopefully you came up with copper 1 sulfide as your name. And let's get busy with those calculations. So I have out a periodic table. Please make sure you have a periodic table handy. So PT, that's my abbreviation for periodic table. Have that out. So the first element I'm looking at is copper. I find the mass of copper. We're just going to use 2 decimal places on the periodic table. So I'm looking at my periodic table. The mass of copper is 63.55. Well, 63.55, and there are 2 atoms of it. And those 2 atoms are highlighted right there. So that's going to give us the mass of copper. And then we've got to find the total mass of the compound to put into the denominator. Let me go ahead and refresh your memory here. So percent composition is equal to mass of the element divided by total mass of the compound times 100. We'll get the total mass in just a second. Let's skip on down to sulfur. Sulfur, there is just 1 atom of it, and as I look at the periodic table, the value that we're going to use there is 32.07. And you can put grams on the end of all of these masses right here. We can work with grams per mole, AMU, just depending on how the question is asked. But those numbers are going to be interchangeable, divided by total mass times 100. The total mass is going to be, if you have out your calculator, the 63.55 grams. Let me change my colors here. We've got 63.55 times 2. That is going to give us 127.1. I'm not too concerned with significant figures at this point. Just don't go crazy with your rounding. And I don't want to see every digit in your calculator either. So 127.1, that's going to be the mass of copper in the numerator. Adding on to that the mass of sulfur, 32.07. And we are going to get 159.17. So that value for total mass, 159.17 grams, goes into your denominator. Okay, heading back over here to our math calculation. You should be able to put all of this into your calculator pretty good. Again, don't go crazy on rounding one way or another, but our percentage here, the top 79.85% copper, and at the bottom we're getting 20.15% sulfur. And a way to double check your answers, go back, make sure that your percentages right here add up to 100% or really close to it. It might be 99.98 or 100.001, something like that. But if you get 100% there, chances are you did the rest of your math correctly. And be sure to look at your periodic table at the correct element. So there's your example for percent composition of a compound. If you would have had 3 different elements in your compound, you would have had 3 different setups. If you would have had 4 elements, you would have had 4 different setups, and you would have ended up with 4 different answers, percentage of each element. Looking at this just a little differently. Find the percentage composition of a sample that's 28 grams iron and 8 grams of oxygen. Here, they're just straight out giving you the mass actually being used, so we don't need to go look at the periodic table. I'm going to rewrite the formula again. Percent composition is equal to the mass of the element over total mass times 100. You need to get used to every time you set up a math problem, if there's an equation that goes with your setup, you need to show what that equation is. So the mass of iron, it gives us as 28 grams. And the mass of oxygen, it gives it as 8 grams. We need to find the total mass of both of those. When you add up 28 and 8, you get 36. So divide each of those by 36 grams, and you are ready to complete your math work. In the top one, 28 divided by 36 times 100, that gives us 78% iron. And in the bottom one, your math will give you 22% oxygen. Please make sure you have your calculator handy and you're going through all of the math yourself and are able to do the function properly. With this particular question, it's worded a little differently. Instead of it asking for percent composition, it's wanting to know how many grams of copper are actually in a 38 gram sample of that copper 1 sulfide. If you recall, in our first example today, we found out how much percent copper, how much copper is in copper 1 sulfide. And the answer for that, hopefully you're looking back at your notes, but in copper 1 sulfide, 79.85% of that compound by mass is made up of copper. So for this question, if this were the type of question being asked, if you had already not done your percentage composition like we did earlier, you would have needed to gone through most of those steps first to find that 79.85% copper before you proceed on. Once you know that copper 1 sulfide is actually by mass 79.85% copper, you can take that value, we're going to turn it back into a decimal, 0.7985, and multiply that by the actual mass of the compound we are dealing with. And they give that compound right here as 38 grams, so times 38. When you multiply that, you get 30.3 grams of copper. So in your 38 gram sample of copper 1 sulfide, 30 grams of it is really copper by mass. In this example, it's also asking you to find percent composition again, but it specifically wants the percentage composition of water in this hydrated compound. So this might be the first time you've seen the formula for a hydrated compound. We've got our calcium chloride, and then that dot means that a unit of calcium chloride would be attached to 2 molecules of water to make up that particular substance. So these are hydrated compounds, calcium chloride dihydrate. So the di using a prefix there meaning your 2 waters. We will only have one answer in this one since it specifically wants water, but there is more work than that needs to be done. If I were to look at the equation, write this down. We're going to go add us a new slide and work this out. So calcium chloride dihydrate. Our goal is to find the percentage of water in this compound. That means we need the mass of water, H2O, divided by the total mass of the entire compound. That's calcium chloride, water all together, times 100. So I'm going to work down in this one to get our answer for percent water. And off to the side, we're going to do some math. So we got to find the mass of water. Well, since water is H2O, We know that we've got 2 hydrogen atoms. I'm looking at my periodic table. So 2 hydrogen atoms times its mass of 1.01. We also have 1 oxygen atom. Well, 1 oxygen atom times its mass of 16 gives us 18.02. But in this case, we do have 2 of those molecules, so we're going to multiply that times 2 to get 36.04 grams. I'm going to plug that in as my mass for water. Please make sure any work we do in class or you're doing on your own, you're showing all this math work along with it. So there's the mass of water, but for total mass of the compound, now we also need to go find the mass of the calcium chloride. So let's work on the CaCl2. Well, for calcium chloride, we've got 1 calcium atom. Let me rewrite some of this. And I'm looking at my periodic table. The mass of calcium is 40.08 grams. So there we go there. And we have 2 chlorine ions, or in this one 2 chlorine ions. The mass of chlorine, looking at my periodic table, 35.45. Once we do the math there, that is 70.90. And now if you want to find the total mass of the compound, you need to add up 36.04, 40.08, 70.9 to get the total mass of the compound. And it looks like you should get 147.02 grams. So we're going to bring that over, plug in the 147.02 grams as our total mass of the entire compound. And whenever you do your math, your final answer should be really close to 24.51% water. So again, problems like this, we are already abbreviating the math quite a bit. Make sure you know how to read your periodic table. Show me the math that you're doing so I don't have to guess where any of these numbers are coming from. And we will all be on the same page. So there is percent composition.